Welcome, I'm Aparna Tagare. In this presentation, we will see a few examples of annuity. Annuity is a sequence of payments of equal amounts with a fixed frequency. Now let us consider one example. Here, rupees 5,000 kept in cupboard on 31st December 2020. Now again, rupees 5,000 kept in cupboard on 31st December 2021. Again, rupees 5,000 kept in cupboard on 31st December 2022. So, a sequence of payments of equal amounts, this 5,000, 5,000, 5,000, it is equal amount. So, sequence of payments of equal amounts with a fixed frequency. That means in year 2020, then again in next year 2021, and again in next year 2022. So here installment is made of rupees 5,000 per year or annually. So this sequence of payments is known as annuity. Now consider, if we keep these 5,000 rupees at the end of 2020 in cupboard, the accumulated value will be 5,000. Now in next year, at the end of next year, the accumulated value will be 10,000. 5,000 plus 5,000. And at the end of third year, the accumulated value in the cupboard, it will be 15,000. Okay. So amount at the end of 3 years is equal to rupees 15,000. But instead of keeping this 5,000 rupees per year in the cupboard, if we want to get more than rupees 15,000 at the end of 3 years, what will we do? We will, instead of keeping it in cupboard, we will invest it in a financial company. So consider this example. Rupees 5,000 invested on 31st December 2020 in finance company at interest compounded at 10% per annum. So accumulated value at the end of 2020 will be rupees 5,000. Now this finance company is giving 10% interest on this 5,000. So now next year, rupees 5,000 invested on 31st December 2021 in finance company, in the same finance company, at interest compounded at 10% per annum. And now in this second year, accumulated value will be 5,500 plus this year's 5,000 rupees. This 5,500, it is 5,000 rupees of previous years plus this 500 interest on this previous year's installment 5,000. So we get accumulated value at the end of 2021 will be 5,500 plus 5,000, it is equal to 10,500. Now again in next year, rupees 5,000 invested on 31st December 2022 in the same finance company at interest compounded at 10% per annum. So again this amount will be 11,550 plus 5,000. This 5,000 rupees is investment of the third year, and this amount 11,550, it is previous year's 10,500 plus 10% interest. So we'll get 11,550 plus 500. The total accumulated amount will be 16,550. Now we can consider the same example in this way also. Okay, so the first installment of rupees 5,000, it get invested for 2 next years. Since we are making investment at the last day of 2020, this first installment will get invested for year 2021 and year 2022, that is for 2 years. Now the second installment of 5,000 will get invested for this year 2000. We are investing it on the last date of 2021, so it will get invested for the next year 2022. So this second installment get invested for 1 year, and this third year's installment we are making at the last day of 2022. So it is invested for 0 years, so it will remain as it is. So this first installment for 2 years at 10% compounded annually will give rupees 6050. The second installment for 1 year at 10% interest compounded annually will give 5500, and this third installment of 500 for 0 years, okay, it will remain as it is, same, rupees 5000. Now if we add these three, we get amount at the end of 3 years is rupees 16,550. Now in this example, the investment is made yearly or per year at the end of the year. So it is known as immediate annuity. The annuity which is made at the end of the period is known as immediate annuity. Now here we can consider like this or like this. So we get the same amount. We can calculate same amount by using one formula, and that formula is, we will see in the next slide. Here this amount of installment 5000, 5000, 5000, it is known as amount of annuity. Now for how many installment, for how many years these 5000 rupees are invested? For 3 years. So number of years or number of installments are 3. Now rate of interest is 10%. So we have to consider these three things: amount of annuity, number of years, and rate of interest. Considering these three values, we can find this accumulated value at the end of 3 years. For that, we have one formula. Accumulated value is equal to capital letter A. This accumulated value is denoted by capital letter A. It is equal to C upon I into square bracket into round bracket 1 plus I bracket raised to n minus 1, where I is equal to R upon 100. Now we have seen that this C, it is amount of annuity. That is, in previous example, here C is equal to rupees 5000. Okay, and number of installments. Now these 5000 rupees are invested per year for 3 years. So number of years n is equal to 3. Now here next letter is I, and it is given that I is equal to R upon 100. Here R is rate of interest. In previous example, R is equal to 10. 10 upon 100, we get value of I. So using this formula, we can find accumulated value A. So annuity is of rupees 5000. So we write C is, it is denoted by C. C is equal to rupees 5000. Since rupees 5000 invested at the end of every year for 3 years, therefore number of annual payments is equal to n is equal to 3. Rate of interest is equal to R percent is equal to 10%, and remember this thing, this interest is compounded annually. I is equal to R upon 100, that is 10 upon 100 is equal to 0.1. So we use these three values C, N, R, and from I we calculate I, and we use this value in this formula. So let us see. A is equal to 5000 upon 0.1. We are substituting values of C, I, and N here in this formula. C is equal to 5000, I is equal to 0.1, 1 plus I is 1 plus value of I is 0.1, bracket raised to n is equal to 3 minus 1. Now only we have to solve this and we find value of A. So 5000 upon 0.1, 1 plus 0.1 is 1.1 bracket cube minus 1. Here a 1.1 bracket cube we calculate, it is equal to 1.331 minus 1. Now we multiply in numerator and denominator by 10. So 5000 into 10, 50,000. 0.1 into 10, 1. So we write this 5000 upon 0.1 as 50,000. Into this subtraction, it is 0.331. Now this product, it is equal to 16,550. Now we have seen already, that is by previous method, The amount accumulated at the end of 3 years is 16,550. Accumulated value is rupees 16,550. So we can calculate the accumulated value using this formula, where C is amount of annuity, N is number of years. If the installment is made per year, N is equal to number of years. And considering that installment biannually or 4 times a year, we find this value of N and we use it here. And I is equal to R upon 100, where R is rate of interest. Now consider same example, but here the change which is made is rupees 5,000 invested on 1st January. Now in previous example we have seen at the end of the year 2020, but here invested on 1st January, at the beginning of this year 1st January, in finance company at interest compounded at 10% per annum. First installment. Now second installment of rupees 5,000 invested on 1st January 2021 in same finance company at interest compounded at 10% per annum. And third installment rupees 5,000 invested on 1st January 2022 at interest is compounded 10% per annum. Now the difference between the previous and this example is, in previous example at the end of the period the installment was made, and in this example at the beginning of the period we are making this installment. So in this case, this 5,000 rupees first installment amount accumulated value is 5,000 plus interest 500, we get 5,500 at the end of 2020. Okay, now second installment, so at the end of 2021 the accumulated value will be interest on this previous plus this year's 5,000 rupees, because these previous year's 5,500 plus 2020 in this year's investment was 5,000. So total 5,500 plus 5,000, it is 10,500 plus interest on 10,500 at 10%, it is 1,050. So accumulated value at the end of second year will be 11,550. In the same way, in third year, these 5,000 rupees get invested on 1st January 2020. Therefore, the accumulated value will be this 11,550 plus this 5,000 rupees, 16,550, and interest on this 16,550 will be 1,655. Therefore, the accumulated value will be addition of these two, 18,205. So we can consider like this, or we can consider in this way also. This first installment of 5,000 rupees, it is invested for 3 years at 10%. Since these 5,000 rupees are invested at the beginning of 2020, so these 5,000 rupees get invested for whole year 2020, then 2021 and 2022. So this first installment is for 3 years. The second installment is for 2 years, 2020 and 2020, since it is made at the beginning of this year. So this 5,000 rupees for 2 years. Now this first installment 5,000 rupees 5,000 for 3 years at 10% will give rupees 6,655. The second installment for 2 years at 10% will give rupees 6,050, and this last installment of rupees 5,000, which is invested for 1 year, it will give 1 year for 10%, it will give rupees 5,500. So if we calculate these three things separately and we add these, we get same amount at the end of 3 years is 18,205. So we can consider in this way or in this way. But the important thing is, in this example, this annuity of rupees 5,000 is invested at the beginning of the period. So it is known as annuity due. In the beginning of the period, investment is made, therefore it is annuity due. Now, we can calculate accumulated value in case of annuity due. The formula to calculate accumulated value A for annuity due is A is equal to C into bracket 1 plus I upon I into bracket 1 plus I bracket raised to n minus 1, where I is equal to R upon 100. The formula is similar but not same as annuity immediate. The difference is, in the case of annuity immediate, this value is only in formula for C upon I. Instead of this C, we have written here C into bracket 1 plus I. So now let us check the previous example. The annuity is of rupees 5000. C is equal to rupees 5000. Since rupees 5000 invested at the beginning of every year. So while solving examples, be careful about these words, invested at the beginning or at the end. According to that, we have to use the appropriate formula. Here rupees 5000 invested at the beginning of every year, so we have to use formula for annuity due for 3 years. Therefore, number of annual payments n is equal to 3. Rate of interest is R% is equal to 10% compounded annually. I is equal to 10 upon 100 is equal to 0.1. We use this formula, we substitute these values in this formula. A is equal to 5000 into bracket 1 plus value of I is 0.1 upon I 0.1 into bracket 1 plus 0.1 bracket cube minus 1. The calculation, yes, 1 plus 0.1 is 1.1. Now, yes, 1.1 bracket cube is 1.331. Then 5 here in numerator and denominator we multiply by 10. So 5000 into 10, 50,000, 0.1 into 10, 10 is equal to 1. This 1.1 and this subtraction 0.331. Now this product, it gives 18,205. Therefore, accumulated value is equal to rupees 18,205. Now, here we have to use formula and find the accumulated value. Now, let us compare between these two, annuity immediate and annuity due. Now, annuity immediate, here the installment is made at the end of the period. Annuity due, in case of annuity due, installment is made at the beginning of the period. So, in annuity immediate, installment is paid at the end of the period. In annuity due, installment is paid at the beginning of the period. Now, for accumulated value, we use this formula. A is equal to C upon I into bracket, into round bracket, 1 plus I bracket raised to n minus 1. And here, in case of annuity due, accumulated value is denoted by A dash. It is equal to C into bracket 1 plus I upon I in square bracket, in round bracket 1 plus I bracket raised to n minus 1 bracket complete. Now, if we compare these two, here we have C, and in case of annuity D, here in place of C we have C into bracket 1 plus I. Only this change is there. Now, present value is denoted by P. Here present value is denoted by P dash. Now, how to calculate present value of the annuity? We use this formula. P is equal to C upon I into bracket 1 plus I bracket raised to minus n. In case of annuity due, P dash is equal to C into bracket 1 plus I upon I, 1 minus 1 plus I bracket raised to minus 1. See, only change is in place of C, here we have C into bracket 1 plus I. Okay. So, relation between A and P, accumulated value and present value of the annuity. A is equal to P into bracket 1 plus I bracket raised to n. Here A dash, accumulated value in case of annuity due, is equal to P dash into bracket 1 plus I bracket raised to n. Now, relation between P, A and C. P is present value of annuity, A is accumulated value of annuity, and C is amount of annuity. So, 1 upon P minus 1 upon A is equal to I upon C. In case of annuity due, 1 upon P dash minus 1 upon A dash is equal to I upon, instead of C, here C into bracket 1 plus I. So comparing these two, and according to example, we have to use these formulae and solve example. Let us see a few examples. First example, find the accumulated value. It is also known as future value of annuity of rupees 800 for 3 years at interest rate 8% compounded annually. Given 1.08 bracket cube is equal to 1.2597. Now here we want to find accumulated or future value. Now annuity of rupees 800, that means value of capital letter C is given, annuity of rupees 800 for 3 years. That means how many installments are made? 3 installments are made, since annually here it is given for 3 years. So number of installments or number of years 3 at interest rate 8% compounded annually. So value of R is given, here C is given, N is given, R is given. So we have all the required values. We can find the accumulated value or future value. Now here consider this thing. If we keep these rupees 800 in our cupboard for first year, for second year 800, for third year, what will be the amount in the cupboard? 800 plus 800 plus 800, it is 2400. But instead of that 2400, instead of that we are investing these 800 rupees annually in a company giving 8% interest compounded annually. So obviously the accumulated value will be greater than 2400. Now let us see. So C is equal to rupees 800, rate of interest R% per annum, I is equal to R upon 100 is equal to 8 upon 100 is equal to 0.08. Now the thing which we have to consider here, in this example it is not given that whether it is an example of annuity due or annuity immediate. That means it is not given that this annuity of rupees 800 is invested at the beginning of each year or at the end of each year. So if it is not mentioned in the example, we have to consider it is an example of annuity immediate. Use formula for annuity immediate and solve it. So N is equal to 3 years. We assume that the annuity is an immediate annuity. Since it is not mentioned in this example, we have to consider it as immediate annuity. Okay. So accumulated or future value, it is equal to A, we want to find. Only we have to write the formula, substitute values, calculate and get answer. So A is equal to C upon I into bracket 1 plus I bracket raised to N minus 1. So C is 800, I, here we have value of I 0.08, remaining values only part of calculation. Here in numerator and denominator we multiply by 100. 800 into 100 we get 80,000. 0.08 into 100 we get 8. 1 plus 0.08, 1.08 bracket cube minus 1. Now here 1.08 bracket cube, this value is given here. 1.08 bracket cube is equal to this. So in all the examples of annuity, this value 1 point something bracket raised to something, it is given in that example, only we have to use it. Okay, so 80,000 upon 8 we get 10,000. This cube is given minus 1, so we get 10,000 into 0.2597. This multiplication gives 2,597. So we get the accumulated value is equal to rupees 2,597. Now if we have kept these rupees 800 per year for 3 years in our cupboard, at the end of the 3 years the accumulated value will be 800 plus 800 plus 800, 2,400. instead of that it is invested at the rate 8% compounded annually, we will get amount which is greater than 2400, and it is 2597. Okay, so I am telling this because while calculating, uh, it may happen that this point by mistake, if this point get given at wrong place, then from the answer you can cross check, or you can roughly find the amount must be greater than 2400. So that's why I'm telling you, consider this example in mind, and roughly you can calculate what will be the value, so it will be useful for cross checking the answer. Let us see one more example. Find the present value of an annuity immediate of rupees 36,000 per annum for 3 years at 9% per annum compounded annually, given 1.09 bracket raised to minus 3 is equal to 0.7722. Now, the two types of annuity, annuity immediate and annuity due. In previous example, it was not mentioned, but in this example it is mentioned that annuity immediate, so we have to use formula for annuity immediate. Now the things required, find the present value. We want to find value of capital letter P, present value. For that, the given things are annuity immediate of rupees 36,000 per annum. That means 36,000 rupees are invested per year, so it is value of C. For 3 years, that means value of per year for 3 years, that means number of installments are 3, or n is equal to 3, at 9% per annum compounded annually. R is given. From R we can calculate I, and using proper formula for present value we can evaluate. So C is equal to rupees 36,000, N is equal to 3 years, R is equal to 9% per annum. From R, we calculate I. I is equal to R upon 100 equal to 9 upon 100 is equal to 0.09. We want to find present value. Now, it is case of annuity immediate. Here in this example, it is mentioned. So, we consider formula for annuity immediate. Present value P is equal to C upon I into bracket 1 minus 1 plus I bracket raised to minus n, bracket complete. Only we have to substitute value of C, I and n here, and we get the answer. So P is equal to 36,000 upon 0.09 into bracket 1 minus 1 plus 0.09 bracket raised to minus 3. Now 0.09, so we multiply in numerator and denominator by 100. So we get 36,000 into 100, we get 36 lakh upon 0.09 up into 100, we get 9. 1 minus this addition is 1.09 bracket raised to minus 3. Now this value, it is given here, only we have to use this value here. So 9 fours are 36, therefore we get this division is 4 lakh into 1 minus, we substitute this value which is given here 0.7722. So 4 lakh into 0.2278, it is 91,120. Therefore we get the present value of annuity is rupees 91,120. Now here consider this 36,000 for first year, then 36,000 for second year, then 36,000 for third year. If we add these three amounts, that is 36,000 into 3, we get 1,08,000. But this present value is less than 1,08,000. Okay, so here we are investing 36,000 for this year, 36,000 for second year. Now obviously present value of 36,000 invested for next year, its present value will be less than 36,000. Again 36,000 invested in third year, its present value will be less than 36,000. So we get this present value is less than 3 times 36,000. Okay, I am simply telling you for cross checking the answer. It is less than 1,08,000, which is 3 times 36,000. So the present value is equal to rupees 91,120. Now let us see one more example. Find the rate of interest compounded annually if an annuity immediate of rupees 20,000 per year amounts to rupees 2,60,000 in 3 years. Okay. Now here we want to find rate of interest. Here I have taken examples using same formula, but there are four values A, C, I and N. So we see first example where we have to calculate accumulated value A. Then we have seen example where we want to find present value. In this example, find the rate of interest. We want to find value of R. Now here annuity immediate, it is mentioned here, so we have to use formula for annuity immediate of rupees 20,000 per year. So 20,000 per year, that means it is value of C, amounts to rupees 2,60,000, amounts to this, that means it is accumulated value 2,60,000 in 3 years. How many installments or how many years are there? 3. So N is given. So we want to find rate of interest. First we list the things. C is equal to rupees 20,000. A, that is accumulated value, is rupees 2,60,000. N is equal to 3 years. We want to find R. Now R here in a formula we have to use I. I is equal to R upon 100. We want to find R. It is a case of annuity immediate. So it is mentioned here in this example, annuity immediate. So we have to use formula for annuity immediate. Now here C and A are given. So we have to use formula which is relation between A and C. You know formula for accumulated value. We use same here. A is equal to C upon I into bracket 1 plus I bracket raised to n minus 1. So 2,60,000 is equal to value of C is 20,000 upon I. We want to find I, and from that value of I we can find value of R. So first we find I using this relation, 1 plus I bracket cube minus 1. Now we transfer I to this side, 20,000 to this side. Okay, this. Now a division of this gives cancelling these 4 zeros. 26 upon 2 is 13 into this I. 13I is equal to 1 plus I bracket cube minus 1. So this 13I, and here we expand this bracket. Here we use this formula A plus B bracket cube. It is equal to A cube plus 3A square B plus 3AB square plus B cube. Okay, so here we use formula A plus B bracket cube and we expand, we get these terms. 1 cube plus 3 into 1 square into I plus 3 into 1 into I square plus 1 cube, and this minus 1 here, minus 1. Now 13I, this 1 cube is 1, 3 1 square into I, 3 1 into I, 3 1 into I square, I cube minus 1. So 13I, we cancel this 1 with this minus 1. Now remaining terms 3 into 1 into I, 3I, 3I square, and this I cube. Now here we have 13I. Now we take I common from these 3 terms. So 13I is equal to I into bracket 3 plus 3I, taking I common from I cube, we get I square. Now we cancel I from both sides. So we get this relation. 13 is equal to 3 plus 3I plus I square. Now we transfer this 13 to this side. I square plus 3I plus 3, and we transfer 13 minus 13 is equal to 0. So we get I square plus 3I plus 3 minus 13 minus 10 equal to 0. So here we get a quadratic equation in R. So let us solve it. So we factorize 3 such that we get a product of factors is minus 10. So I square is equal to plus 5i minus 2i minus 10. So taking common I plus 5, taking minus 2 common, minus 2 into bracket I plus 5, I plus 5 into bracket I minus 2 equal to 0. Equating each bracket separately with 0, I plus 5 is equal to 0 or I minus 2, this bracket is equal to 0. So we get two possible values of I is equal to minus 5 or I is equal to 2. Now here I is equal to R upon 100, and we know that rate of interest R is non-negative, therefore I must be non-negative. So since R is not negative, I is also non-negative. So I is not equal to minus 5. Only possible value of I is 2. So I is equal to 2. Now we want to find R. Relation between I and R is I is equal to R upon 100. Here we substitute I is equal to 2. 2 is equal to R upon 100. Therefore R is equal to 2 into 100, 200. So we get the rate of interest is 200% per annum. Okay. So here in this example, using same formula for A, we find rate of interest which is equal to 200% per annum. Now let us see last example. Find the number of years for which an annuity of rupees 500 is paid at the end of every year. If the accumulated amount works out to be rupees 1655 when interest is compounded annually at 10% per annum. Now here annuity of rupees 500, C is given. Next thing, accumulated amount is rupees 1655, that means value of A is given, 10% per annum rate is given, R is given, and we want to find number of years, that means value of N. Okay, now the most important thing, at the end of every year, that means we have to use formula for annuity immediate. So C equal to 500, A accumulated value which is given rupees 1655, R is equal to 10% per annum, I is equal to R upon 100, 10 upon 100 equal to 0.1. We want to find N. Now we can calculate roughly, that is 500 rupees are invested and annuity is of rupees 500 and accumulated value is this. How many times we have to invest 500 to get amount which is nearly equal to this? Okay, so 500 plus 500 plus 500, we get 1500, and interest is given, so obviously it is greater than 1500. So roughly we can calculate the answer, but let us see by formula. It is case of annuity immediate. It is mentioned at the end of every year. So it is case of annuity immediate. We use, since A is given, C is given, we use this relation between A and C. A is equal to C upon I into bracket 1 plus I bracket s to n minus 1. Only we have to substitute these values in this formula. So 1655 is equal to 500 upon 0.1 into bracket 1 plus 0.1 bracket s to n minus 1. We transfer 0.1 here, 500 in denominator is equal to this. So multiplication of these two, 165.5 is equal to this. Again we transfer this 1 to this side. So 500 into 1, 500. So 165.5 plus 1 into 500, 500 upon 500 is equal to this. 1.01 plus 0.1, 1.1 bracket raised to n. Now see here, there is only one unknown here in this. Only we have to calculate or simplify this expression and we get value of n. So from previous slide, 165.5 plus 500 upon 500 is equal to 1.1 bracket raised to n. So this addition gives 665.5. We write this 500 as 5 into 100 is equal to 1.1 bracket raised to n. Dividing this by 5, we get 133.1 upon this 100 is equal to 1.1 bracket raised to n. Now this division gives, only we have to give this decimal point here. 1.331 is equal to 1.1 bracket raised to n. Now see here, here this value is equal to 1.1 bracket raised to n. So obviously this 1.331 must be some power of 1.1. We know that it is 1.1 bracket cube. So 1.1 bracket cube is equal to 1.1 bracket raised to n. So since bases are same, indices are same. So 3 is equal to n. We get the answer n is equal to 3. Therefore, number of years for which the annuity is paid is 3 years. Okay. So that's all for today. So revise the formulae and difference between annuity immediate and annuity due. In this presentation, we have taken examples of only annuity immediate. In next presentation, we will take examples on annuity due as well as annuity immediate and other types. Okay, that's all. Thank you for watching.